What if I told you that the entire future of artificial intelligence might not depend on a new, fancy algorithm, but on a huge change to its most basic physical foundation? And that foundation is made of a material you would never, ever expect, one that could completely unlock the next decade of AI.
Yeah, it sounds a little weird, right? We think of AI as, code and silicon. But what if the industry's biggest roadblock and its next massive breakthrough lies in something as simple and as ancient as glass?
So here's what we're going to cover. First, we'll break down the huge problem facing today's most powerful chips. Then, we'll introduce the surprisingly simple solution. After that, we'll look at the global race to get this stuff to market. And finally, explore the challenges and the incredible new possibilities this all opens up. Okay, let's dive right in. To really get why we need a totally new foundation, we first have to understand what we're building on right now, and more importantly, why it's starting to completely fall apart. For years and years, the unsung hero of the chip world has been the organic substrate. You can think of it as the circuit board that's inside the chip package itself. It's the platform that everything is built on. It's a resin-based material that has worked incredibly well for us. But the insane demands of modern AI are pushing it way past its breaking point. And that breaking point? It actually has a name: the warpage wall. See, today's AI chips, especially those massive GPUs, are getting unbelievably large and ridiculously hot. We're talking over 1,000 watts of power. All that heat and all that physical stress is causing the organic substrate to literally bend and warp. And this isn't some far-off theoretical problem. It is happening right now, causing real failures and seriously limiting performance. And when these substrates warp, the results are bad. You get way more errors in your data. The physical connections between the different parts of the chip get weaker. It becomes almost impossible to etch the tiny microscopic pathways needed for the next generation of chips. And if things get hotter than 150 degrees Celsius, they just start to fail. The industry has well and truly hit a wall. So if the old foundation is literally crumbling under the pressure, what are we going to build the future on? Well, the answer, as it turns out, is crystal clear. It's glass. Now just look at how dramatic the difference is here. Where the old organic substrates bend and warp, glass is incredibly rigid and perfectly flat. Where the organic surface is rough, glass is, get this, 5,000 times smoother, which is absolutely critical for preventing tiny defects. And that 150-degree temperature limit? Glass is totally stable all the way up to 400 degrees Celsius. It's not just a small improvement. This is a total game changer. Let's put a hard number on that stability. We are talking about 50% less warpage. For a chip designer, that means you can build bigger, more powerful, more complex systems and know that they're going to be way more reliable. And the electrical benefits are just as incredible. With 40% better signal integrity, the data signals are just cleaner, with fewer errors as they travel around. And that means you waste less energy on fixing those errors, which could cut the power needed just to move data around by almost half. That is a massive efficiency win. Okay, so one of the key pieces of magic here is something called through-glass vias, or TGVs. So instead of mechanically drilling tiny holes like you do in organic substrates, you use lasers to etch these ultra-precise pathways right through the glass itself. This lets you make connections that are 10 times denser. 10 times. You can pack so much more power into a much smaller space. And the benefits just keep coming. The whole chip package can be up to 25% thinner. It paves the way for future 2-nanometer and even 1.4-nanometer chips. And, okay, this is the really mind-blowing part, it opens the door to something called co-packaged optics, which means using the glass itself to transmit data with light instead of electricity. We are definitely coming back to that. Now, when you have a technology this revolutionary, you just know it's going to kick off a high-stakes global competition. And that's exactly what's happening as companies scramble to take glass substrates from the research lab to the mass market. And, this wasn't some overnight success. The basic research started all the way back in 2009 at Georgia Tech. But look at how fast things have picked up recently. Just this year, the first factory opened. Next year, we're already expecting to see working devices and the very first commercial shipments. And by 2028, this is expected to be a key feature in major high-performance chips. So who's in the lead here? Well, a company called Absolix, which is part of South Korea's SKC, is the first one to market. But the giants are breathing down their neck. Samsung is aiming for mass production next year. Intel has said this is a core part of their future strategy. And maybe most telling of all, even TSMC, the world's biggest chipmaker, who actually looked at this years ago and gave up, is now aggressively back in the game. So why does all this matter? Well, for a company like NVIDIA, it could mean they can build even more powerful GPUs, potentially doubling their memory bandwidth. For data centers, it means you can pack way more computing power into the same space and cool it more efficiently. And for everyone from AI researchers to companies like AMD and Tesla, it means a whole new generation of more powerful tools is right around the corner. Of course, a change this big is never easy. So let's wrap up by looking at the real-world hurdles that still need to be cleared and the incredible potential if and when we do. There are really three major challenges. First up is fragility. I mean, it's glass, right? These panels are unbelievably thin, and making them without any cracks requires totally new tools and processes. Second, the supply chain. Suddenly, everyone needs this special kind of glass and the laser equipment to work with it, and it's already getting strained. And third, geopolitics. This is a fierce technology race between nations, and whoever can scale up production the fastest is going to have a huge advantage. But even with those challenges, the financial stakes are absolutely enormous. The market is expected to grow from about $1 billion next year to over $4 billion within a decade. The motivation to solve these problems is, well, it's massive. And this brings us back to the ultimate prize. Because glass is transparent and can guide light, this whole technology is the gateway to putting photonics directly into the chip package. The end goal here is to have chips talking to each other, not with electricity, but with light, which would completely shatter the data bottlenecks that are holding back AI systems today. It's such a powerful thought, isn't it? The foundation for the most complex machines we've ever built could be a material we've been using since the dawn of civilization, now engineered to carry the very future of intelligence itself. This shift from electricity to light is about as fundamental as it gets. So once we finally shattered this bottleneck, it leaves us with a really fascinating question. What's going to be the next great wall for AI to come up against and break through?